Hi, this is Adam Griffin with the second video for this week's physics videos, and this is problem 85. So the problem is a child in danger of drowning in a river is being carried downstream by a current that flows uniformly at a speed of 2 meters per second. The child is 200 meters from the shore and 1,500 meters upstream from the boat dock from which the rescue team sets out. If their boat speed is 8 meters per second with respect to the water, at what angle from the shore should the pilot leave the shore to go directly to the child? So we can draw this. So this will represent our river, and we have our child, which is the red dot, and the dock and boat, which are in the same place at the start. The boat is represented by the blue dot and will travel in this direction, while the child will travel in this direction downstream. So the first thing to realize with this is that when it says 8 meters per second with respect to the water, it is not talking about with respect to the shore, obviously. So because we know that the stream travels 2 meters per second this way, we can take that into consideration when we are traveling upstream. So we know that the boat is actually traveling 6 meters per second with respect to the shore. So to find the angle at which the boat should leave, which is the goal of the problem, we have to look at the distances between all of these different points. So the child, which is 200 meters from the shore and 1,500 meters upstream of the dock, we can get rid of all of that extra stuff and put it into a more geometric looking diagram. So we have our child up here and the boat, which starts down here. We know that since the child is traveling at 2 meters per second and the boat is traveling at 6 meters per second, this length, if they are meeting at a point and both are moving in a directly straight line, this side will be 1/3 of the length of this side. So if the child is moving straight down the river, they will continue to stay 200 meters from the shore. So we know that, and they will have traveled an X number of meters. So we know that the boat has traveled upstream 1,500 meters minus X meters. So we can have that triangle, just this one right here, and we can do the Pythagorean theorem. So we have 200 squared plus 1,500 minus x squared equals 3x squared. So we can do that out, and we get 2.29 million equals 8x squared plus 3,000x, which you can either graph out or do the quadratic formula for, and it'll show you that x equals 380. And we can check that by seeing if 1,500 minus x equals something that is, I apologize, not 1,500 minus x, this 3x right here, it should be just a little bit longer than the 1,500 minus x and should be 3 times as long as this still. Well, which is how we found it out, but it is good to double check. So we can isolate this triangle completely, and we get that once we plug in x for these side lengths, we get 1,120 meters for this this length and 1,140 meters for this length. So this theta, the angle, will equal the inverse tangent of 200 over 1120, because that is, for this angle, opposite over adjacent. So that'll come out to 10.1 degrees. So the boat needs to leave at an angle of 10.1 degrees to go directly towards the child. So that is how you do this problem, and thank you.